do one simple thing. Listen carefully to every single word. I guarantee 80 to 90% of this topic will be ready in your mind right now. Physics is actually very easy.
Product of vectors, scalar product, vector product, and properties of scalar product. All of these we will cover in this lecture. From paper point of view, this is very important. It contains many short questions, long questions, as well as MCQs. I will highlight short questions and MCQs during the lecture. So close your notebook, put your pen aside and pay attention. Listen carefully to every single word that comes out of my mouth. I'm repeating. Listen carefully. I'm repeating this. Close your notebook. Put your pen aside and listen carefully to every single word that comes out of my mouth. Then, in coming 20 to 25 minutes, this topic will be ready in your mind. It's my guarantee. Just listen carefully to every single word. Let's begin. Product of vectors. Product means multiplication. Product of vectors. Vector. Vector means having magnitude and direction. Product means multiplication. Vector means having magnitude and direction. Let's quickly revise them. Scalar and vector. For example, I have 4 markers. 1, 2, 3, 4. I have 4 markers in my hand. So, n is equal to 4 markers. Another example. If I apply a force on this duster, a force of 5 Newton on this duster. Another example, I apply a force on this duster in this direction, a force of 5 Newton. Force of 5 Newton. Force, n unit vector. Now, 5 Newton is the magnitude. 5 Newton is the magnitude. N unit vector. N unit vector is the direction. Force has magnitude and direction. Direction in this way. Force is applied in this direction. Force is applied in this direction. N unit vector represents the direction in this way. 5 Newton is the magnitude. N unit vector is the direction. So force has magnitude and direction, both magnitude and direction. But the marker has no direction, only magnitude, but no direction. Only 4 markers. Only 4 markers. No left, right, east, west, no direction. Just a magnitude. but force has magnitude and direction, and the direction is this in this way. The force is applied in this direction. So force is a vector quantity for marker. This is a scalar quantity and this is a vector quantity. Hope you got it. Now, graphical representation of a vector. Graphical representation of a vector. Draw a line of 5 centimeter and put an arrow. 5 centimeter line with an arrow. 5 centimeter represents the magnitude 5 Newton. And arrow shows the direction and unit vector. Direction in this way. So this is the graphical representation of this vector quantity. Graphical representation of this vector quantity. Similarly, here we have two vectors. Vector A in this direction, vector B in this direction. Now come to the topic. Product means multiplication. Multiplication of vectors. When two vectors are multiplied, the result may be a scalar or a vector. Sometimes a scalar, sometimes a vector. So we have two types of product, scalar product and vector product. First, we will discuss scalar product. Scalar product. What is scalar product? When two vectors or the product of two vectors gives a scalar quantity, then the product is called scalar product. For example, look here. Force is a vector quantity. We discussed here force. Force is a vector quantity. This force is a vector quantity. Displacement. Displacement is also a vector quantity, but the work is a scalar quantity. Force is vector, displacement is vector, but the work is scalar. So, product of two vectors, vector, multiplication of two vectors. Product of two vectors gives a scalar. Product of multiplication of two vectors, f multiplied by d. Product of two vectors gives a scalar. Product of two vectors gives a scalar, then the product is called scalar product. This is the example of scalar product. Example, another example. Again, force is a vector quantity. Velocity is also a vector quantity, but the power is scalar quantity. Again, two vectors gives a scalar. Product means multiplication. Multiplication of two vectors. Product of two vectors gives a scalar quantity. Then the product is called scalar product. Again, when product of two vectors gives a scalar, then the product is called scalar product. Now come to the vector product. Vector product. Again, similar. Product of two vectors gives a vector quantity, then the product is called vector product. For example, look here. Torque. Moment arm is a vector quantity. Force is a vector quantity. Torque is also a vector quantity. Here, product of two vectors gives also a vector quantity. Then the product is called vector product. Product of two vectors gives a vector. Then the product is called vector product. Product of two vectors gives a vector. Then the product is called vector product. If product of two vectors gives a scalar, then the product is called scalar product. Another example, angular momentum. In angular momentum, position vector is a vector quantity. Linear momentum, product of mass and velocity, is a vector quantity. Angular momentum is also a vector quantity. Again, product of two vectors gives a vector quantity. Then the product is called vector product. Product of two vectors gives a vector quantity. Then the product is called vector product. Now, it is represented by cross between two vectors. Cross between two vectors, vector A, vector B. Cross between two vectors. Cross between two vectors. It is represented by cross between two vectors, cross between two vectors. And the formula is A cross B is equal to AB sine theta n unit vector. Why n unit vector? Because it is a vector product. In vector quantity, there must be a unit vector n or I, j, k or any other. So in vector, there must be a unit vector, but in scalar, there will be no unit vector. Look here. Formula of a scalar product. A dot B, AB cos theta, no unit vector because it is a scalar, but in vector there will be a unit vector n. It is represented by dot between vectors. Dot between vector. There cross between vector, but here dot between two vectors. It is represented by dot between vectors. Dot between vectors. And the formula is A dot B is equal to AB cos theta. Now, a little bit explanation. Consider two vectors A and B making an angle theta with each other. Consider two vectors A and B making an angle theta with each other. Making an angle theta with each other. Two vectors A and B. Equation 1, this is equation 1. Equation 1 can be written as, this equation can be written as A dot B is equal to AB cos theta, AB cos theta. Now, they both are same, but a little bit difference, order is changed. Why? Now, pay attention here. An important concept which we learned in the previous lecture. Now, pay attention. We will break down this vector A into its components. How? For this, we will draw a perpendicular line from the head of vector A on vector B. Perpendicular line. Perpendicular line means the angle is 90 degree. Perpendicular line means the angle must be 90 degree. Perpendicular means 90 degree. To break a vector into its component, draw a perpendicular line from the head of vector A on B. Then from here to here. This is A cos theta. The component of A along B is A cos theta. This is A sin theta. But we don't need it here. The component A cos theta is the component of A along B. A cos theta is along B. This is the component of A along B. Look here. A cos theta is equal to component of A along B. This is the component of this vector, component of vector A along vector B. So this is A cos theta is the component of vector A. This A cos theta is the component of vector A along B, and B is the magnitude of vector B. B is the magnitude. B is the magnitude and this is the component. Component and magnitude. Now come here. Equation 1 means this equation can also be written as A dot B is equal to AB cos theta, AB cos theta. Both are same. They both are same, but a little bit difference, only the difference of bracket, pair of brackets. Now why? Now we will divide, or we will break down this vector B into its components. For this, we will draw again a perpendicular line from the head of this vector B on A. A line, perpendicular line from the head of vector B on A. This is perpendicular line because the angle is 90 degree. This angle is 90 degree. Now, from here to here, this is B cos theta. This is B cos theta. To break down vector B into its component, we need to draw a line from the head of vector B, a perpendicular line from head of vector B on vector A. This is a perpendicular line from the head of B on vector A. Now from here to here, this is B cos theta, component of vector B along A. B cos theta is equal to component of vector B along vector A. Now here, this is the component of vector B. B cos theta is the component of B along A. Component of B along A, vector A. B cos theta. B cos theta is the component of vector B along A. And A is the magnitude of vector A. A is the magnitude of vector A. Now here an important concept, a key point. Look here, pay attention. We will convert this mathematical step into theory. And this is another definition of scalar product. This is the definition of scalar product. Look here. Magnitude of vector, product is multiplication. Product of magnitude with the component. Product of magnitude with the component. This is the definition of scalar product. Again, I'm repeating, pay attention. Product is multiplication, they both are multiplying with each other. Product of magnitude with the component. Product of magnitude with the component along the vector. Again here, product of magnitude with the component. From these two mathematical steps, we conclude that. So scalar product is the product of magnitude of vector with the component of vector along it. This is the second definition of scalar product. This is the first definition and this is the second definition. And it may come as a short question. This definition and a little bit explanation, and these are the example of scalar product. Now properties of scalar product. Import- Properties are too much important, extremely important. First property, it obeys commutative law. What does it mean, commutative? It obeys commutative law. In simple words, this is the first property. In simple words, commutative means 2 multiplied by 3 is equal to 3 multiplied by 2. 2, 3, 3, 2. 2 multiplied by 3 is equal to 6. 3 multiplied by 2 is equal to 6. This is commutative law. 2, 3, 3, 2. A, B, B, A. 2, 3, 3, 2. Same. A, B, B, A. This is commutative law. It obeys commutative law. This is the first property. Now here, a short question may come in a paper as, the question may come as, prove that scalar product obeys commutative law. Let me repeat this. The question is, prove that scalar product obeys commutative law. In answer to this question, you have to write from here to here. It's very simple. Look here. A dot B is equal to AB cos theta. Reverse the order. AB, BA, then it will become B dot A, hence proved. This is the answer to this question. Very simple. Second property. This is the first property. It obeys commutative law. Second property. Dot product of two orthogonal vectors are always zero. Orthogonal means perpendicular. Dot product of two perpendicular. Orthogonal means perpendicular. Two perpendicular vectors is always zero. Let me explain this. Its second property. Two perpendicular vector. For example, this is vector A and the second vector. This is vector B. And they are perpendicular, so the angle will be 90 degree. Perpendicular means having angle of 90 degree. When dot product of two perpendicular vectors, they are perpendicular, and perpendicular the angle will be, in perpendicular the angle must be 90 degree. So A dot B, AB cos theta, and in perpendicular theta is 90. So AB cos 90. A dot B as it is equal to as it is, AB as it is, cos 90 is equal to 0. You can verify on your calculator. Cos 90 is equal to 0. Then AB as it is, AB multiplied by 0 is equal to 0. Anything multiplied by 0 becomes 0. Anything multiplied by 0 is 0. Hence proved. No, is always 0. Dot product of two perpendicular vectors is always 0. Hence proved it's all 0. Is second question. And this question may come as, prove that dot product of two orthogonal vectors is always 0. I'm repeating the question. The question that may come in the paper as, prove that dot product of two perpendicular vectors is always 0. In answer to this question, you have to write from here to here. from here to here. Hence proved dot product of two perpendicular vectors is 0. Similarly for unit vectors, we have three unit vectors I, j and k. Look here, we have three unit vectors. X-axis, I is along x-axis. This is y-axis. J is along y-axis. I is along x-axis, J along y-axis, and K. K is in this direction, perpendicular to both. This is X, Y, and Z. Z is in this direction, and I, J, and K. K is in this direction along Z. So the angle between I and J is 90 degree. Look here. I dot J. Angle between I and J is 90. When angle is 90, it becomes 0. So I dot J is equal to 0. Now J dot K. Look here, the angle between J dot K. J, this is I, this is J, and this is K. Angle between J and K is also 90. If the angle is 90, then it becomes 0. So J dot K is 0. Similarly, K dot I is also 0 because the angle is 90 degree between these both. Now, pay attention here, a note. We know if they are perpendicular, the dot product is 0, but dot product is also 0 when a null vector comes. Let me explain this. As we know that look here, three multiplied by 0 is equal to 0. Any number, for example, 283 multiplied by 0 is equal to 0. Any number multiplied by 0 is equal to 0. So what is the null vector? Null vector is the vector having magnitude equal to 0. Null vector is the vector with 0 magnitude. Null vector is a vector. Null vector is the vector. Null vector is the vector with 0 magnitude. So any vector multiplied by 0 will be 0. So dot product with null vector means dot product with 0 is always 0. Dot product with null vector, and null vector is the 0 vector having magnitude 0 is 0. So listen carefully. Dot product is 0 in two cases, in two situations. The first case or first situation, when the angle is 90 degree, then the dot product will be 0. And in second case, dot product is 0 when there is a null vector, then the dot product is 0. This may come as a short question in the paper or in MCQs. Dot product is 0 when there is null vector and also when there is angle of 90 degree or perpendicular. Now come to the third part. Third property, dot product of two parallel vectors has maximum value. Parallel vectors. Number 3, parallel vectors. Vector A and vector B. They are parallel. Look here. They are perpendicular, means the angle is 90. The angle is 90 degree. Now angle decreases to now 30, 20, 10, 0. Now they are parallel. In parallel vectors, the angle is 0. So in parallel vector, the angle is 0. A dot b AB cos theta, and theta in parallel vector is 0. In perpendicular, theta is 90, but in parallel, theta is 0. They are parallel. Now A dot B as it is, AB as it is, cos 0 is equal to 1. You can check by using your calculator. Cos 0 is equal to 1. AB multiplied by 1 is equal to AB. Now, this is second property. Dot product of two parallel vectors has maximum value. This is the maximum value. Or dot product of two vectors is equal to the product of their magnitude. You can also write is equal to dot product of two parallel vectors is equal to the product of their magnitude of A and magnitude of vector B, product multiplication of their magnitudes. Now dot product with itself. Look here, pay attention. Dot product of vector with itself, product of A with itself means with itself, vector A with vector A. So angle is 0. A dot A is equal to AA cos 0 with itself. AA, both are same direction, angle is 0. Cos 0 1, A square. So A dot A is equal to A square. Right here, dot product with itself is square of its magnitude. It's the answer to this question. Dot product with itself is square of its magnitude. This is the magnitude of A, square of its magnitude. Now, similarly for unit vectors, I dot I is equal to 1 1. Now look here. Here we write AA, but here A dot B is equal to AB. Why? But here we wrote 1 1. Why? Because we know the magnitude of I. The magnitude of unit vector is 1. The magnitude of I is 1. Magnitude of J is 1. K is 1. But we don't know the magnitude of A and B. Magnitude of A can be 5, 6, 2, 1, 0, any number. We don't know. That's why we write A and B. But here we know the magnitude. Magnitude of I is 1. That's why we will write the magnitude here. So I dot I is equal to 1 1. Angle between I and I. Angle between I and I. Both are in same direction. Angle between I and I is 0. Cos 0 is equal to 1. 1 multiplied by 1, 1. Cos 0, 1. K and 1 multiplied by 1 is equal to 1. I dot I is equal to 1. Similarly, J dot J is equal to 1 and K dot K is equal to 1, similar to I dot I is equal to 1. Now, fourth property. In fourth property, number 4, dot product of two anti-parallel vectors is negative. Anti-parallel means one vector in this direction, other in this. They are anti-parallel. They are parallel and they are perpendicular. Now, between anti-parallel means vector A in this direction and vector B in this direction. Then the angle will be then the angle will be 180 degree. They are anti-parallel. And between anti-parallel the angle is 180. A dot B, AB cos theta, and theta is 180 between anti-parallel. Cos 180 is equal to -1. You can verify on your calculator. AB as it is, A dot B as it is, equal to as it is. Now AB multiplied by -1 is equal to minus AB. Hence prove, it may come as a short question, prove that dot product of two anti-parallel vector is negative. As a question it may come. Now fifth property, dot product in terms of rectangular components. In previous lecture we studied resolution of vector or the rectangular components of a vector. We studied that vector A is equal to AXI plus AYJ, and vector B is equal to BXI plus BYJ. We studied this in the previous lecture. I will put the link of this lecture in the description. If anyone is unable to understand, go through it first. This is in 2D. In 2D we have x and y. In 3D we have x, y and z. In 3D we have ax, ay and az with k unit vector. Similarly, in bx, by, bz, k unit vector. Now here, look here, a dot b is equal to the value of a. The value of a is ax, ay, az, ax, ay, az. Then dot and dot as it is b, and the value of b is bx, by, bz, bx, by, bz. Now look here, for multiplication I dot I is equal to 1, but I dot j is equal to 0. Look here, I dot j is 0, so no need to write it. Similar, I dot k is also 0, I dot k is 0, but I dot I is 1, I dot I is 1, so we will write I dot I ax px, ax bx, and I dot I is 1, then other two are 0, then j with j, ay by, j dot j is 1, j dot j is 1, then k with k, az, bz, k dot k is 1, but k dot j is 0, k dot I is 0, so no need to write. This is rectangular components, dot product in terms of rectangular components. Now look here, as we know that a dot b is equal to ab cos theta, here ab is multiplying with cos theta, on the other side it will be divided. When we move ab to the other side, it will be divided under a dot b, our ab. Now cos theta as it is, ab as it is, vector a dot vector b, is equal to ax bx, ay by, az bz, ax bx, ay by, az bz. Only we replaced a dot b with its value. Hope you got it.